Now we're looking at example 5 from our 2.4 set of notes. We're asked to find the equation of the tangent line of the following function, and here it is, at this specific target x value. Now, when we're looking at trying to get the tangent line, we know that we first have to get the tangent slope. And as a result, when we're looking for a tangent slope, we know that that's going to comprise of a derivative. So what we're going to go ahead and do is take the derivative of this. Now, certainly, yes, you could go ahead and distribute all these items and end up with some polynomial as one line. And you could do that, but I think it would actually require more work for you to do that as opposed to just using your product rule. So for right now, we're just going to go ahead and let f be this first piece and g be our second part. So then we have f is equal to x to the fourth minus 3x squared plus 2x, and g is equal to our x cubed minus 2x plus 3. Now just going ahead and taking the derivative of both sides, we end up with f prime is equal to 4x cubed minus 6x plus 2. Just using, again, the power rule here. With g prime, comes out to be 3x squared minus 2. This is a constant that would just drop out. Going ahead and doing our cross, it looks like our derivative, y prime, comes out to be 4x cubed minus 6x plus 2 times x cubed minus 2x plus 3 plus our f g prime. So x to the fourth minus 3x squared plus 2x times 3x squared minus 2. Now, instead of going ahead and distributing this and again getting some polynomial, again, what we're really just looking for is the equation of the tangent line. All right, that's really the only thing we actually care about here. And we notice a special number, this target x value, being 0. Well, we can go ahead, and since we found the derivative, essentially this really is just your tangent slope at a bunch of different x values that you can potentially plug in. But we're hoping for the derivative, or the tangent slope, specifically at the target point 0. And so when we go ahead and throw in 0 into the function, we end up with a lot of these just coming out to be 0. So for example, we would have this first piece coming out to be 0. Negative 6 times 0, that's still just 0. The only thing that's really constant here is this plus 2. So that's the entire first set of parentheses. For the second one, this is 0. Minus 2 times 0 is 0. Plus 3. Plus, all of these are going to be 0. Times, again, 0 right here. Now, you certainly could have distributed all of these items and ended up with the tangent, the derivative of that, which gives you tangent slopes at different target points. But there was something special about this specific one, in that it was our target point being at 0. And most things, as a result, are just going to cancel out. So here we end up then with just 2 times 3 plus all of this. This would be 0 times negative 2, but that'll eventually just come out to be 0 anyway. So it looks like our tangent slope comes out to be 6, particularly at this target point. Now again, we have our target x value, but we have to find out what is the corresponding y value to use point slope. So to find y, we're going to go ahead and throw that into the function. We have y is equal to, again, this is 0 plus 0 plus 0. Anywhere that there's an x, where essentially it's going to be 0. There's 0 plus 0 plus 0 times 0 plus 0 plus 3. But again, we end up with 0 times 3. And that's just coming out to be 0. So it looks like our point is 0, comma 0, our target point. And from that, we can then go ahead and construct the equation of our line using our target point and our tangent slope. So just using our point slope, y minus y1 is equal to m times x minus x1. And throwing those in for our values, we end up then with y minus 0 is equal to 6 times x minus 0. Well, on the left side, we just have y is equal to, distributing on the right, we end up then with just 6x. So here then would be our tangent line to this particular function at this particular target point, 0, 0. Now again, just reiterating, you could have absolutely distributed all these items in and found different tangent slopes at different target points. But we had a very, very nice target point, 0, 0. As a result, you didn't have to do all the distributing, because when you throw it in there, all those are going to be zeros anyway. So it's just a little bit of a strategy to maybe think ahead in terms of what is your problem really asking for to save you some time. But again, though, that is example 5 from our 2.4 set of notes.